All right, so section 4.1 and 4.2, they're all about proofs, and so I'm not going to do. I'm not going to get too heavy into proofs. We are going to talk a little bit about them and a little bit about how to go about some of them. Um, um, so we're going to go about them a little bit. What I'm not going to do is hold you responsible to do them like in a perfect way. Um, the idea of that being is I want you to be exposed to the concept of proofs, but it's not going to be this huge, giant mess of them. Okay, so as we go through them, that's just something I want you to keep in your mind as we go. So we're going to define odd numbers and even numbers. Oh, I did odd first. I'm going to do even down here. Okay, so by definition, a number is odd if you can write, or even rather, if you can write it as a sum, or you can write it as 2 times k, where k is an integer. So you pick me an integer, cool, it's 5, great. 2 times 5 is 10. 10 is even because you can write it as a multiple of 2. An odd number is written as 2k plus 1. Okay? Pay not really attention. Jay, the book used an M and an this and an R, and it doesn't make any difference. This is the gist of it. That's kind of why I do that, is because I want you to be aware it makes no difference which book you're in. Okay? Different books will do it, set it up differently. Different books will talk about this and that. We'll go about it from there. Now, this is some number theory is what it's called. That's why that is the basis for what they're doing the proofs on is number theory stuff. Okay, so that's where these are coming from. Now you can have all kinds of proofs, geometric proofs, all sorts of proofs. That's not what I want to get into. The reason that they don't do that is because it's a very simple, straightforward things. They just want you to get into the concept of thinking logically. Now, suppose you had an odd number and an odd number. An odd number. And you're going to take the sum. So the sum of 2 odd numbers. I don't know what's wrong with my writing today. It's worse than normal. Okay. Now, what do you know about that? Well, we're going to prove is even. Okay, cool. Right on. So what I'm going to do is I'm going to say let's let R equal 2k plus 1. Okay. And I'm going to let, I'm not going to use S. I'm going to use M. I'm going to let that be 2. And I'm going to use a different integer, P plus 1. Sweet. Whatever. Who cares? So when I take R plus M, that is the same as saying it's 2k plus 1 plus 2p plus 1. And then, of course, if you simplify that a little bit of algebra, you can write that as 2k plus p, because they have a 2 in common, plus another plus 2 more. You see that? And so in reality, what you could do then is write this as 2k plus p plus 1, like so. But what is k plus p plus 1? Those are all, what are they? Well, they're all integers. That's right. Nice. So in other words, this could be written then as 2, and then I'll use a different value, just 2z, let's call it. Okay, and up here maybe I'm making a little note to self. K, P, and Z all integers. Okay, but what does it mean that if R plus S, or R plus M rather, is equal to 2Z? By definition, this is odd. So by definition, this is, I'm sorry, did I say odd? This is even. Okay, and therefore it is proved. Okay, so when we go about these things, we're going to kind of talk through some more of them as we go along. But I'm going to be looking more for can you explain what you're doing than a 2-column proof, things of that nature. I don't really believe that's going to help you in your whole life to do a bunch of those sorts of things. Thinking logically, of course, is going to help, and it's not going to hurt you to do a little bit of algebra. Okay, so the sum, cool. I'm going to set that up as the sum. Clearly, I'm going to add the left sides of the equal signs and the right sides, and voila. Then it's just algebra, and when I get to the end, it should come up with what I'm looking for. Okay, that's kind of the goal or the plan as we go along. Okay, we'll do some others. All right, here is another one here, perhaps. For all integers n, if n is odd, then this is odd. All right, so for all integers n, if n is odd, right, then n minus 1 over 2 is odd. Right? Now, in this situation here, if I'm looking at that, I'm like, I don't know, do I buy that? Do I buy that? Maybe I do. Let's try one. Let's try 7. 7 minus 1 over 2. Oh, interesting. Well, that's 6 over 2. Okay, that's 3. Sweet. What if I did 9 minus 1 over 2? That's 8 over 2. Oh, it's 4. Uh-oh. Uh-oh, they said it's odd. I showed that it can be even. So by counterexample, all right, by counterexample, right? So I disprove the statement because I gave a counterexample of that, all right? We've done things like that in the past. So in this section, as you're looking through it, there will be some that will be done. There will be some that will be done by a straight up proof, and we're going to do some more of those in a second. There will be some that will be done, we're going to show a counterexample of it. So we can also sometimes refer to that as a contradiction. So you run into a contradiction, then uh-oh, there you go. Okay. Here's a fun one here. For all integers n, if n is odd, n squared is odd. Let's try that. For all n, for all integers n, if n is odd, n squared is odd. I don't know, let's find out, shall we? Okay, so if it's odd, let's see what happens here. So, all right, cool. So I'm going to have n is equal to 2k plus 1. Okay, well, it said n squared. All right, n squared. If I do it to one side, I do it to the other side. 4k squared plus, what else do we got here? 4k squared plus 4k plus 1. Cool. This, when I look at it there, I go, okay, well, wait a minute now. What happens to this guy here? You're like, well, Mr. Grimm, Jay, check it out. K squared could be it could be odd, or it could be even. I concur. You are correct, ma'am, sir. That's true. However, when you times it by 4, what are you going to get? Even. Jay, what about here? Bro, what about here? Oh, cool. Oh, yeah. Well, 4, which is really just 2 times another. This could be written as 2 times 2k, right? 2k is even times 2 more. It's also even. So even. So even plus 1. Uh-oh. She's odd, right? So that is a true statement. It will always be true. Now, could I write it better? Yeah, I think I can. I believe I can pull a 4k out of these guys. You with me? That leaves me with a k plus 1, right? Right, plus 1. Okay, well, if I think about that for just a jiffy, okay, I can also rewrite this as 2 times 2k times k plus 1. But what is k plus 1? It's just a different integer. Are you with me? Plus 1. So then when I think about this, what is, okay, now this is an even integer. This is any integer, right? When I multiply them, I'm still going to get just another integer. So this times this is some new integer, m, let's say. What do I end up with? It does, again, because it doesn't matter. This is just any integer here, yes? So this times this is an integer. So 2k times z is just a new integer m. 2m plus 1 is of the format, what? It's an odd number. And that will always be true. This is how I want you to word things. So this is just, we're working it out. All right, that is doing exactly what I was told to do. Square both sides. All right, algebra. And then I'm going to beat into submission, beat it into submission. And by that, in this case, I know what I'm looking for. I'm looking for it must be of the form 2k plus 1, or there, whatever. In this case, 2m plus 1. I must get it back to that format. So I'm just going to do some algebra to see if I can get there. Again, I'm not going to make a big deal about it. I don't need a whole lot of dots. Although, if you want to do this that's kind of cool. A little mic drop action there. Therefore, boom! But that's cool. Yeah, that makes me happy. If that makes you happy, makes me happy. Okay. Get another one here. That sounds fun to me. Ooh, this is cool. If A is odd and B is even, A is odd, B is even. Not sure why B is capitalized, but whatevs. Okay, then they're making this bold statement. Then 2A plus 3B is even. I don't know, dude. I don't know. So I'm just going to say let's let A equal 2K plus 1, whatever. And let's let B equal not 2K. I'm going to do 2M specifically because they don't have to be the same value, K, right? Well, that's cool, whatever. So watch me take 2 times this dude plus 3 times this dude. Cool. Awesome. And I guess this, me personally, I'd probably just play musical chairs here. That's the easiest way to do that. Then don't. Okay, well, what is this? 3M is, by definition, it's a new integer, yes? That's cool. And what is 2 times R? Oh, that's even. Hot dang. So then over here, friends, check this out. If you multiply that through, well, you don't have to multiply it through. You go, wait, what is 2K plus 1? 2K plus 1, by God, that's an integer. So then I could rewrite this as 2z or something. What? And then I get 2z. Shut up. I get 2z plus r. Wait a minute. Z plus r, integer plus integer, is integer. Kaboom! So I get 2a plus 3b is of the form 2q. Then, hence, bam, it is even. Okay? And again, we are going to be somewhat one-trick ponies on this guy, but again, the reason for that is because they just want you to get comfortable with the idea of proofs. That's it. That's all. Okay. Yeah. Cool. Now, as soon as I say something like this, okay, as soon as I say this next thing, I want you to think, what's the first thing that comes in your mind? Okay. There exists an integer n such that six n squared plus 27 is prime. That's hot. I don't know. I don't know. Okay. Okay. Well, let's see what happens here. What do you want to do? Yeah. So, first thing that comes to mind is, gosh, there's a lot of numbers in there, but as soon as I can come up with one, as soon as I can come up with one that isn't prime, all right. When I look at this, I should say it this way: when I do this, I need to show that as soon as I see that, my first thought is my first thought about this guy is always, what can I do to make this a better problem? What can I get to an answer that makes sense on this guy? Can I get this down into a way where I can show it's always going to be a product? And I think the answer is I think I can. So if you think about this, what do these guys have in common? They have a 3 in common. So you're going to have 2n squared plus 9. You with me? Now, it's quite possible you could sit here and play games all day long, and you can go, oh gosh, I feel like I never get to a point where sometimes you can just see, oh, well, like 5's not going to work, or whatever, or 5's going to work, and okay, there it is. Or sometimes, sometimes you can do these things, it's quick, but sometimes you can't. So let's think about this. They have a 3 in common. It's a little bit of algebra. Now, here's my question. This number right here, okay, is a number. I'm going to write this as, I don't know, we'll call it R, okay? But if you think about it, what is R? R is a product of what? 3 times whatever's in here. By definition, what does that say to me? It says to me that R is never prime because it's always a factor of 3. Always. Okay? And so in that situation, I say to myself, I say, what can I do to write this? Prime means the only way you can do it is to be a product of itself and 1. Therefore, if it factors anything else, there's any other factors of it, it's not prime. And that just makes your life a little bit easier to fool with. Okay? Well, the product of an even integer and any integer is even. Can we prove that? Let's find out. The product of an even integer. What the Sam Hill does that say? Integer and any integer is even. I don't know. Let's find out. So let's just, again, start off with R and, I don't know, P, because I can. Now let's times them together, because by God, that's what it said. All right. Q. Wait. What do these guys have in common? Well, they have a 2k in common. That's true. Which would leave a 2m plus 1. Well, that's box office. But maybe I want to leave the k in there just for good time. I think I do. I think I'll leave the k in there, because why take it out? Hey, integer times integer is integer, plus an integer is an integer. Shut up, 2z. What does that tell me, friends? It tells me bam, bam, bam. Therefore, I approved it, because I can, again, beat it into submission and make it look what I want it to look like. In this case, even. Okay? That's the sort of thing that you'll be doing a lot of. I'll do one example here of a. I'll do one that's a little trickier maybe, and see what you think. Oh, don't do that one. Oh, maybe I'll leave that one for the homework. Oh, let's do this one. For each integer n, n squared minus n plus 11 is prime. Okay? So the question states, to determine whether it's true for all integers, true for no integers, true for some, or false for the other, and true for some and false for the other, justify your answer. Well, in this situation here, okay, there's only the numbers between 1 and 10 that I'm interested in. Are you with me? It's only the numbers between 1 and 10. Therefore, when I do this problem, my first thought is we can do what's sometimes referred to the method of exhaustion. And the method of exhaustion simply says, let's look at each one of them and see where we end up. And if it works for all of them, we can, because it's quite clear with just using Excel, for instance, it's not hard to do. Now, mind you, it may not work for numbers past 1 to 10. Okay? I honestly don't know. Heck, I don't even know if it works for these ones or not. But I think it's handy. So equals this fella squared plus that fella minus 1, I think it was. Is that right? N squared, oh, minus n plus 11, you big dope. Minus n, sorry, plus 11. Hot diggity dang. Kaboom! And what do we want to know? We wanted to know, are they prime? Like Neon Dion. Prime. Prime, 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 prime. All prime. Now, how did I know that was going to work? Okay, did I know it was going to work? Well, no, I showed by exhaustion that it does, in fact, work. By the way, if I had to go to infinity, could not prove it that way. Now, what comes to my mind is this. Does this baby factor? No. Does not factor. The fact that it does not factor says what? Well, remember on this previous page over here somewhere, look at that. We was able to factor this fella. Therefore, we could show that there was not prime. But in this case, can't factor it. Because I can't factor it, what does that say to me? I'm going to get prime numbers. Wait, is that always true, Jay? I don't know. Let's find out. Suppose you had an equation that was n squared plus, we'll do a nice easy one here, n squared plus n minus 12. Oops. Let's do this. Well, that we know factors n plus 4, n minus 3, right? Right? So let's plug a number in. Let's do 4. Let's do 4. That'd be 16 plus 4 is 20 minus 12 is 8. And interestingly enough, what you would find is on this one, I'm just going to go ahead and change the function if that's okay with you, because I feel like I can. Oh no. Oh no. Yeah, cool. So A1 square plus A1 minus 12. Kaboom. And what do you notice about all those? None of those are prime. Are you with me? None of them are. Okay? And again, it comes down to does not factor. It's going to be prime. Factors will never be prime. Okay? So think about that as we go along. Okay? Kind of an interesting way of looking at it, I guess. Okay? So let's do another one here. Okay? Excuse me. Okay. Actually, I'm going to pause you for a second. Okay, so I'm just going to run through a few things symbolically here. So we've talked about it. I want to show you some of the symbols in case you've never seen them before. So if n is even, okay, that's how you say if and only if in logical symbolic form. There exists an integer k such that n equals to k. Yeah. Yep. So, and so as you're doing these, just be aware of that. Cool. All right, and then of course if n is even, odd rather. Plus 1. There we go. So we talked about that. Just want to show you the what it looks like in symbolic notation. Okay, so we know what prime is, but here's how we would write prime. So n is prime if and only if. Okay, for all positive integers r and s. And if n is equal to rs, then either r equals 1 and s equals n, or vice versa. In other words, the way you're saying that is you're saying that the only factors of itself are itself and 1. Okay? If n is composite, which is the opposite, in case you've forgotten, the opposite of being prime, this could be in a composite number. Same exact thing. okay, such that n is equal to rs. And furthermore, you must write this. And what are you saying by that? You're saying that, hey, this can't, S can't be 1 and R can't be 1, and neither of them can be N. Okay? So that's what composite means. Okay? Just, again, the reason I'm running through this again, you know to talk about it, but we're showing, I just wanted to kind of run through and show you some of the symbols a little bit. Okay? Yep. That's pretty cool, I think. What else do I want to talk about? Again, I don't really want a ton of words from you. I would like a little blurb off to the side of what's going on. That's kind of the extent of what I want to see. I don't want to see a ton of extra, like, I don't want to have to try to read a novel when I'm looking at your little proof off to the side here. Okay? I think we'll do one more here. If n is odd, then that, no, I don't want to do that much more. Well, yeah, I guess let's do that. Okay, so if n is odd, we're going to prove that this is true. So if n is odd, -1 to the n power is -1. Okay. Now we need to prove that's always true, right? Obviously, it's -1 to the 1 is -1. Duh. Okay, and that's true. -1 cubed, -1, obviously. But if I were to prove it, I would say this. Well, let's let n equal 2k plus 1. So that really then becomes 2k plus 1. Well, wait now. Hold up. This can be written as -1 to the 2k times -1 to the 1th. Yes. Yes. Nice. And so, wait a minute now. What happens here? Okay. Well, this can be thought of instead of that as this. And this, if you look at it, well, what's going to happen here? -1 to the whatever power is either going to be +1 or -1, correct? Doesn't make any difference. Am I right? It doesn't matter if it's +1 or -1. This right here, when you do it, doesn't matter if it's +, -1, because what's going to happen? I'm going to square it, and it's going to become +1. Are you with me? Times what? -1 to the 1th, which is -1. Hence is my answer. Boom, boom, boom. Done. It has been proven. Therefore, oh, kaboom! Okay? That's the game. Okay? Always, always, always in this section, start off and do what they told you to do. It's -1 to the nth power. Cool, and n is odd. Then I'm going to throw in 2k plus 1 and down the race as I go. Not terribly difficult. Again, you know where you're trying to get to. And in this section, they pretty much tell you that it can be proved, in essence. They said prove that it's true, okay? Now, in the real world, you might be trying to prove something that's true, but in fact, it can't be done. That's a bear cat, okay? But you just follow the rules. Oh, there you go. Again, oftentimes you know what the right answer is going to be based on observations. Interestingly enough, currently in our news media right now, the hydroxychloroquine. Some people are like making a huge deal. Oh, it doesn't work. I mean, oh, it works. Okay, here's the deal. You know why people think it might work or had an idea it might work? It's because there was shown to be in the African countries where there's a ton of malaria and people take hydroxychloroquine all the time. There would seem to be a lack of coronavirus. You'd think there'd be plenty of it over there, but no, there isn't that much. You're like, oh, that's interesting. Also in this country, people on rheumatoid arthritis and lupus is a very known medicine for those things, and the rate of infection amongst those patients is quite a bit lower. That is, they tend to avoid getting it. That is, it acts as a prophylactic. You don't get it instead of it necessarily curing you. Now, that said, okay, is that they recognized a pattern, therefore they went ahead to, okay, now let's do a trial, let's see if we can prove it, okay? Now, that said, that's a similar process here, that as you're looking at things, if your job was to do number theory, and you're like, gosh, I feel like this cubed plus this is going to be an even number every time. It sure seems like it is. again, you know where you're going. Therefore, you should be able to kind of, beat it into submission and get where you need to go. That is, you need to get there. Again, back to statistics, one of my favorite things on the planet. But if you think about it, like oftentimes you will see the weirdest things that they'll find. Well, there's something that with it in a starfish that only lives in the bottom of the sea that actually seems to cure this one brand of whatever, cancer or whatever. Well, how in the devil did they know that? Well, it turns out, blah blah, something happened, and there's a prevalence of this thing doesn't get this disease or whatever. There's reasons for why they thought that. It's not like someone randomly thought, I'm going to cut the arm off a starfish and rub it on a tumor and see what happens. Okay, there's the idea that they've seen there's some sort of correlation there. Now, again, is necessarily one causing the other one, or is there some other deal at play? We don't know. That's why then you do testing after the fact. But that's why. Again, that's where they get these things. The same thing is true for proving. Typically, you don't go, oh, by God, I'm going to try to prove that this equals that. Well, what are you doing? Well, the reason that you're trying to prove this equals that is because, in other words, you think that it might. It seems that all roads lead there, and whatever. And so, therefore, it's simply a matter of, going from here to there. You're not going to go prove that 7 equals 4. That's ludicrous. But you might try to prove that, you wouldn't prove 7 is an odd number, but you might prove something about the number 7 or whatever, because that would make sense, okay, is part of something that you've been dealing with, okay? Enough said about that. I will make a new video for section 4.2.